Hey everybody, welcome back to another Emory Security YouTube video. My name is Evan Isaac, and today we're going to be taking a look at the API section of the Vulnet CTF. So in the section, we have 5 vulnerabilities that we need to exploit and retrieve the flags for. So let's jump right into it. It says Shadow of the Nations, and it says you've been authorized to access the system, but it is really yours. Look deeper. Identity overlaps in surprising ways with the rogue nation vulnet.com. I just finished up the web section, so those are the URLs for that. And we see here that we do have a register page. So we'll just quickly register a new account on this application. And we can see here that it says the role is user and then also our username with the view favorites. So let's head on over to Burp Suite and see what we have to work with. So we'll go over to HTTP history and we could see what is going on. We're going to look at the rogue nation vulnet server. So we could see here that it just says favorites and we don't have any favorites here because we don't have any made. I don't actually know if we can even make one, but what we can do, however, is we can try a couple things. So whenever you see API endpoints, one of the first things that you normally want to do is check to see if there's other API endpoints. So you can just start playing with the different kind of URLs and see what ends up happening. When we remove favorites, we can click on it and we can see that we also retrieve different information now. And what you can do at this is because it's a numerical value, you can just start upticking. So you could do 1 through 100. You could do, whatever you really want. If this was UIDs, it would be a little bit more challenging. But because this is a numerical value, it should be a lot easier to brute force, right? And you could just start guessing random things, right? So we can assume that admin is number 1, but let's just assume for a second that admin is not number 1. Let's say it's number 100, right? And we don't really know which number it is. We can come over to intruder. We can click on 89 and click add. And what this is going to do is this is going to put these little squiggle lines, or these, I like to call them double S symbols, in place. So once you do that, you're going to head on over to payload type and select numbers. And we're going to just put from 1 to, let's just say 100. And it's going to be sequential. And we're just going to keep upticking with the max digits of 3. So we're going to start the attack. And as it goes, we can see that we're getting different lengths. So when we look at the 89, we saw our user. When we look at the 1, we see the administrator with the flag. And if we keep going down, we can keep seeing different people, different users, different IDs. So we can head on over to the ID 1 and copy the flag and paste it into the challenge. So that's the Shadows of Nation challenge down. So the next challenge is called the token. And it's going to have to do with JWTs and how to go about exploiting JWTs. So it says the portal uses tokens to identify who you are, but are they trustworthy? A slight shift in what you present might take you beyond your current reach. What you hold may not be what it seems. And we have the JWT website here. Again, we do have a login page that we need to sign into, but here we could see that it says view my data. And it says that our role is currently set to user. So again, what we're going to do is we're just going to try a couple different things. And something that I like to use is something called JWT Auditor. So if you go to JWT Auditor, we can just look at it and see what there is. So we have the decoder, and we can go to Burp Suite to go about decoding this. So we'll go to proxy and HTTP history. So the API user, we could see that we have the user information as well as the JWT. So when you copy on over to the JWT decoder, we can come over here and we could see that it does decode a few things, right? So it decodes and it says that it is a HS256 with the type of JWT. We have a signature here as well as the payload, which is the ID, the role, as well as the expiration. You can also do something pretty cool, which is try to brute force the secrets on the JWT auditor. So if you just put it over here and click start brute force, it's going to do everything on the back end to try to brute force the secret for you. This does not work, unfortunately. You can try different word lists, but it's not going to be able to crack this specific JWT. However, what you can do is you can go over to the JWT editor, you can click load JWT, and you also will need to supply the secret key. Now we need to find the secret key on this specific application. And sometimes developers do silly things like forget to make sure that comments are withdrawn from production environments. So if we click on view page source and we scroll down a little bit, we can actually see that we have a hint here that says the ID is 2, the role is admin, the expiration date is a bunch of 9s, as well as here is the secret. So what we're going to do is do just that. We're going to go back to the auditor and we're going to put the secret in as this. We'll set the ID to 2, the role to admin, and then we'll just supply a bunch of 9s here. So we'll just put 9 9s, so 3, 4, 5, 6, 7, 8, 9. We'll click on generate, and we can see that it was generated successfully. If we head back on over to Burp Suite, and we just send this over to repeater, so now that we have this new token, we can just fix it up a little bit so the formatting is correct. And when we click on send, we can see that we are now unauthorized. This does not seem to be working. Let's try to change this up a little bit. Let me see if maybe it does need 10 different 9s. Let's try to paste it on in once again. And we're going to need to fix it up one more time. So let's see if this starts working now. And when we click send, we can see that we are now the CTF administrator. So it looks like you need 10 9s, not 9 9s. It's good to know. So make sure to follow the rules. And we can see here that we are the admin, but we don't have a flag. Now, like I stated before, there's different ways to go about doing this, right? We want to brute force the API. We want to figure out what endpoints are valid, what endpoints are not valid. So to start, we could try to do API user, and then we could just try to type in 2 and click send. We could see that that's a 404 not found. Maybe we could try users with plural, and we could see that that's also a 404. If we try to remove users, however, I would click on send. We could see that we do end up retrieving the flag, so JWT token rotation pwned. And this was very interesting. It's something that I actually stumbled on for quite some time because I didn't see A, the comment in the source code, and B, I couldn't find the API for quite some time. I was very, very, very confused. And then when I removed the /user, it magically worked. So something very important to try out on CTF challenges because a small hiccup like that can cost you a lot of points within these challenges. So that is the second challenge done. Moving on to the third challenge, we see that says, welcome to Volnet's internal portal. A series of interconnected APIs lie behind various sections like shopping, travel, and something darker. Your access is limited. Find your way in. Something important is hidden, buried beneath layers of structured data. And we can see here that we do have GraphQL. If you don't know what GraphQL is, it is very annoying and painful to work with, but we're going to do it anyway because that is the challenge. So we're going to just log in as MRE, and we see here that we do have a couple buttons. So if we just start clicking on them, we can see that we are retrieving some data. When we click on hack, we can see that we need to go to the GraphQL endpoint. So when we go to the GraphQL endpoint, we can see that we do have a method not allowed. So in the proxy's HTTP history, we can see that we do have that GET request that we were talking about before, and we're going to send it on over to repeater. And a neat trick that you can do inside of Burp Suite is you can right click and then click on change request method to be post. And what this is going to do, this is just going to modify the request and then also add a few different things that we need. So here we're just going to change this to application JSON. And then we're going to also supply a couple of JSON things here. When we click on send, we can see what happens. And we do retrieve an error message that says something about the debugger. So that is a good sign because that means that we know now that it is a Python server in case we needed that information. But what we can actually do is we can go over to GraphQL Voyager and we can try to use the GraphQL Voyager to potentially see any information regarding the schema. So we can click here, go to introspection, and we can click on copy. We're going to just make this into a single line. Okay, so now that we have the introspection on one line, we could try to click send and see what happens. And we can see here it says introspection is not allowed for non-admins. So that means that we cannot use introspection on this application because they have power protections in place preventing us from using the introspection query. Now, the introspection query is very useful if it was enabled where we can see all the different kinds of, I guess you can call them tables. I don't really know exactly what you would call them, or you could just see the entire schema. And once you have that, you can paste it on into Voyager and you could see everything having to do with the schema, and then you can go about finding vulnerabilities that way. So because I play a lot of CTFs, something that I normally try is just to do users, because most of the time every application does have something having to do with users, and almost every application has to have an ID associated with it. So when we click on send, we could see what happens, and we could see that there are 5 users on the application. We could try some basic things. So for instance, because we are looking for a flag, we could try to put users and then flag in here. And we could see that it does reveal all the different kinds of flag values, this being the flag. All right, so the fourth challenge says Service Hustle. Welcome to Service Hustle, bustling two-side marketplace where customers post jobs and providers compete for work. The platform looks polished, but something is off. Beneath the surface of bids, jobs, and dashboards lies a vulnerability that could unravel the trust holding it all together. Your access is limited for now. Somewhere in this system, secrets are hidden, and only by probing the application's flow will you uncover the key to progress. And here we have the URL. So we'll just head on over to this URL. So once again, we do have a registration page, and we're just going to quickly type in our standard stuff. And we can see here that we have a couple things. The first is we have a bunch of different jobs that have an API jobs. So when we click on one, we can see that we get information about each job listing, and we could set a specific bid. So we could do 1, and then we could just leave a note. So we could put something like cross-site scripting vulnerability, and we'll see if we have to do something having to do with that again. When I click on enter, we can see that there is a cross-site scripting vulnerability, but I don't know if there's really going to be much going on here. Because this is most likely going to be a Python application, we can also try something like 7x7 or SSTI. So when we do that, I actually did it completely incorrectly, so that's not going to work. I messed up the payload, so we're going to head on over back to the dashboard. We'll select a different one, and we'll just try this again. So we'll do 7x7, and we'll put 2 brackets there. Click on bid, and when you do that, we see that it says 49, because 7x7 is 49. So we know for a fact that we do have an SSTI vulnerability. Now, something that you could do, which is kind of neat when it comes to these kind of challenges, is you can do something called config.items. And what this is going to do is this is going to show you all the configuration information on the back end, which in our case, it's going to end up showing us the flag, which is somewhere in here, which is right here, SSTI token hijacking. There's other ways you could probably go about doing it. This is the easiest way that I found to do it, but you could probably find a payload on payload all the things, and it should work just fine. But this was my method of choice. So we'll copy this and we'll paste it into the challenge. Lastly is the most difficult challenge on this CTF, which is called CineVault. And essentially it is a movie ticketing site where posters shine, seats sell out, and everything looks perfectly normal. You're a regular customer, browse showtimes, sign in and register, pick a seat, manage your bookings. This service, nothing else is promised. If you poke around, you might find the application doesn't behave quite the way it seems. And here we do have the URL. We can click on register and quickly register once again, and we can just start scoping out this application. So we see the now showing, and we could see buy tickets. So we could just come here and buy one. And when we could see here that it says the booking ID is a UUID that's completely randomized. So there's nothing much going on having to do with that. When we head on over to Burp Suite, and we can see that there is a post request for the /buy endpoint, and there are 2 specific parameters that we could play with. So we can head on over here and try it out again. And it says here that we're redirecting to the dashboard when successful. If we put in a single quote, we could see if something else happens, and it looks like we do have an internal server error. But when we try to do it again, we can see here that we actually get the exact same error message, meaning that this is probably not vulnerable to SQL injection. So we need to find a different way to go about doing things. Inside of the profile, we could see that there are 2 forms that you could do, the avatar URL as well as the bio. And here we can also put a media proxy URL or just a standard URL. So you can either go through GoBuster, or you could just look at the prompts that you've been provided. Because this is a little bit of a sneaky, guessy tactic kind of thing, you can kind of assume that you're going to have to deal with something having to do with the media proxy, because why would that be there? Why wouldn't they just put something like URL or something within this form? So we could just try to do something like HTTPS, and then we could try google.com and see if it redirects. So we can click Save Profile, and here it says Profile Updated. but we don't get any sort of redirection. Nothing is coming back as google.com here, so we're not going to worry too much about that. There's probably a different way to go about doing this. After some time, if you do a GoBuster scan, you'll see that there's actually a /media/proxy endpoint. And when you go to it, it says that you're missing the URL. So if we go over here, we could just type in URL and we could do something like HTTP and then 127.0.0.1, and we could just try port 80 again, and we could see if something comes back, and it says forbidden. In our last episode, we saw something having to do with SSRFs with the file protocol. And if we do /etc password, we could see that we do retrieve the etc password this way. So there are numerous ways to go about doing SSRF. It doesn't have to be just an HTTP site. It can also be with the file protocol. You can use Gopher. You can use accept. You have a bunch of different options that you could do. You could also use PHP to encode and decode specific things. But here we could just try to get the flag by doing something like flag.txt. And it says the file is not found. So we're going to have to go about finding this file. And when it comes to CTF challenges, most of the time they're going to be under /app.py directory. When we click on enter, we can see that we now retrieved the entire thing, the entire code base of this challenge. We now have complete access to, and we can now take a look and see what is going on. If we scroll up a little bit, we can actually see the flag is right here, and it's just a very long flag. CineVault leak super session token bypass exploit master flag 2025. This is a very, very long flag, but it's a pretty cool trick to see on these kind of CTFs, where if you go to app.py, you can potentially extract the source code, and then from there you can go about finding out the flag within the source code. Sometimes it's in an environment variable, which then you need to look at the source code and try to figure out how to go about doing it. But because this is already within, the flag is within the source code, we don't need to worry too much about that. So we'll just copy the flag on over, submit it, and that'll be the end of this CTF. Like I said before, this is a very fun CTF, and if you did enjoy, please let me know in the comment section down below. But please like, subscribe, and I'll see you in the next one. Take care.